Aging happens in your cells, quietly, every second. And one of the clearest ways we've ever found to measure it comes down to something microscopic, your telomeres. Inside each of your cells is a nucleus. Inside that nucleus are chromosomes, long strands of DNA that carry instructions for how your body grows, repairs, and functions. At the end of each chromosome is a protective cap called a telomere. It's made of repeated sequences of genetic material, and its only job is to keep the rest of the DNA from fraying or fusing with other strands when your cells divide. The more your cells divide, the shorter those telomeres become. It's a natural process, but there's a limit. When telomeres get too short, the cell stops dividing. It either becomes senescent, sluggish, and inflamed, or it self-destructs. That's aging at the cellular level. Telomeres don't count birthdays. They count damage. They're not a reflection of your clock age. They're a reflection of your accumulated stress, your nutritional quality, your sleep, your exposures, and your ability to recover. This is why some 50-year-olds are biologically younger than people in their 30s. Their telomeres are longer because their bodies have been under less strain. Now here's where things get interesting, because in physics, time isn't absolute either. Our lifetime is relative to the condition of our telomeres, just like time in the universe is relative to speed and gravity. Einstein proved that time can speed up or slow down depending on the forces acting on it. It's not just an idea, it's been measured. A clock in deep space ticks faster than one on Earth. A clock near a massive planet ticks more slowly than one floating farther away. Near a black hole, where gravity is extreme, time slows down so much that what feels like minutes to one observer could be years to another. This is called time dilation, and it means that time is relative. But what does this have to do with your telomeres? Think about your body. It's not just living in time, it's producing it. Every heartbeat, every cell division, every signal sent across a nerve is part of your own internal clock. And your telomeres are a physical record of how fast that clock is running. Just like gravity can slow time in the universe, certain biological forces can slow down the rate at which your telomeres shrink, giving your cells more time to live. And just like velocity or stress can accelerate time in relativity, biological stress can speed up aging in your cells. When you're living with chronic inflammation, poor sleep, malnutrition, or psychological stress, your cells don't function efficiently. They replicate under tension. They burn through protective mechanisms. They lose telomere length faster, and the clock speeds up. Studies have shown that people who live under constant stress, like caregivers for sick family members or people in unstable environments, have significantly shorter telomeres than their peers. Their biological time is moving faster, even if their calendar age is the same. But the opposite is also true. In 2009, Elizabeth Blackburn won the Nobel Prize for her work on telomeres. Her research showed that lifestyle interventions such as improved diet, physical activity, and stress reduction can slow telomere shortening. In some cases, they may even increase telomere length slightly by activating an enzyme called telomerase, which helps rebuild the ends of chromosomes. This means that your biological time is not fixed. You can slow it. You can change the rate at which your body wears down. Physical activity plays a key role. Movement, especially strength training and interval-based cardio, stimulates pathways that protect cells from oxidative stress. It improves blood flow, glucose metabolism, and mitochondrial function, all of which are linked to slower telomere shortening. Sleep is just as critical. Deep sleep is when your body clears out damaged cells, balances hormones, and performs neurological repair. People who sleep less than 6 hours a night consistently show shorter telomeres than those who get 7 or more. Nutrition matters too. Diets high in antioxidants, fiber, and omega-3 fats are associated with longer telomeres. Ultra-processed foods, refined sugar, and alcohol are linked with shorter ones. It's about giving your cells the raw materials to repair. and removing the triggers that force them into overdrive. Stress reduction isn't optional. High cortisol levels degrade telomere length, but practices like meditation, breath work, time in nature, or simply engaging in activities that bring a sense of calm have been shown to slow this erosion. Connection matters too. People with strong social relationships and community ties have healthier telomeres than those who live in isolation. You can't stop time, but you can stretch it. You can change how quickly your cells run through their division cycles. You can delay the breakdown, and the proof is in your telomeres. Aging isn't just a passive process, it's a reaction to input. It's your body keeping score, and telomeres are one of the cleanest metrics we have to read that score in real time. If your telomeres are shrinking slowly, it means your body is in repair mode more than it's in damage mode. It means you're giving yourself enough time to recover from the strain of living. It means your biological time is closer to stillness than free fall. But if they're shrinking quickly, it means your system is under pressure. It's rushing. It's burning through its resilience without restoring it. And that shows up in energy loss, mood instability, metabolic dysfunction, and the early onset of age-related decline. It also shows up in long-term health risk. Shorter telomeres are associated with increased risk of cardiovascular disease, cognitive decline, cancer, and immune dysfunction. They're not the cause, they're the canary in the coal mine. This is where the comparison to time dilation gets real. Just as a clock in deep space runs differently than a clock in Earth's gravity, your telomere clock runs differently depending on your cellular environment, which you control. When you move your body, when you sleep deeply, when you reduce exposure to inflammatory foods and thoughts, when you reconnect with other people, you are slowing your biological time. You are not reversing age, you're changing its slope. No matter how many years you've lived, you still have control over how many healthy, functional years remain. You are still shaping the future performance of your body. You are still influencing your brain, your heart, your hormones, your immune system. Telomeres are a mirror. They reflect how hard you've been running and how much recovery you've allowed. You can slow the damage. You can buy time with science, real interventions, and real improvements. You don't have to accept the speed of decline as inevitable. Einstein showed us that time can bend. Now biology is showing us that yours can too. Thanks for being here. Let us know in the comments how you're working to slow your own biological clock. And if this helped you rethink aging, subscribe. We'll keep connecting the dots between science, health, and time.